Stefan Jensen, welcome to this interview. You are the CEO at Optipeople, and at Optipeople, you look into different kinds of data that can help support production companies in moving towards more sustainable, both, I guess, in terms of the natural sustainability, but also the financial sustainability, both of those. And today we're talking about some of the most important data points, data insights that you see that companies are looking into to adjust their production for now, and of course, coming into the future. And before turning on the mics, we identified a couple of different bullets, and I think we should just start right into it. The first one that you mention is energy. Can you explain to me what is the energy KPI and why is it important?
Yeah, thank you. Energy is many things. So for most people, it's all about kilowatt hours or CO2 emissions. Mm-hmm. But as such, energy can also be temperature, humidity, pressure, flow, which are data points to make sure that your production is running as it should be running. Mm. So for us as a, let's say, data company, if it's measuring voltage, amps, watts, turning into kilowatt hours for the ESG, for the compliance reporting, or for saving energy, is as such the same way we treat it as if it's a temperature data point or if it's a humidity data point that is important for the actual product that you're producing. Mm-hmm. But those data points are really something that we see is a drive out there, energy and process data.
And why is it a relevant point to look at for production companies?
It's sort of a twofold thing. Number one is that we saw it a couple of years ago where suddenly the gas price spiked to unseen levels. Mm-hmm. And that sort of put people's mind into something. We have to do something in terms of our cost here. We have to look at this. Then it slowed down a bit now, but now we see that the legislation is now catching up. So, of course, the bigger companies will have the most demands first, coming from the EU and tippling down to the national governments and regulatory standards, really. Mm. But what is good, I think, about it is that those, let's say, data points or measurements are also trickling down to smaller companies. So the suppliers, the sub-suppliers to the larger companies. And therefore they then have to let's say, you supply into the wind industry and you have a big, let's say, top of the food chain investor or OEM manufacturer who says, well, all our suppliers, they now need to be able to tell us what is the CO2 emission of how many kilowatt hours was spent on making this part for our product standard.
And collecting this energy data, of course, you can look at your energy bill. You can look at your how many kilowatt hours you're using. But are there any other ways of collecting these data?
Yeah, we see exactly as you're saying. A lot of people now have, and that's accessible on national websites even and so on, that you might have the kilowatt hours used for a whole building. But in a manufacturing building, there might be many machines, there might be many departments within that building. Mm-hmm. And that is where we see people are starting to put in sub-meters, as you would call them. Mm-hmm. And there you can go down to say, well, now I have a cell of 3 lines or 3 machines. I'm putting in a sub-meter so I know at least what is the total energy consumption from these 3 lines. Mm-hmm. But we also see it down to line level. So you can do it down to product level. And a drive off that is, it has become much easier to implement such sensors or such meters in terms of both the install part, the accessibility in terms of pricing, but also how easy is it to then collect that data actually visible without standing looking at a physical meter.
I was just about to to ask because I thought now, okay, you've got the different data points, you've got data collecting in, and you may have aggregated some of the data points, or you have some sort of interface where you can kind of dig down. But how are companies using that energy data to propel themselves or to be more competitive? What is the usage of that other than just knowing, well, the cost, I guess?
Yeah. Well, as such, if you're not using data, it hasn't got any value in itself unless you have to use it for a database and it's part of, if the food agency needs to look into it in 5 years' time. But in the day-to-day life, we see companies use the process and energy data in a few ways. Number one is that they use it for their operations. So basically, an example could be, we want to see, are we spending any energy when we're not supposed to? So are we running a machine? Is it, for example, running in sort of an idle state? We just had that case where they wanted to look at, it has sort of a middle state, this machine, and we don't want it, there's no purpose for it to be in this idle state if we're not producing anything. Then it should just be turned off. So that's more from an operational, literally turning off as we can relate to at home, having the lights on in a way. So that's from an operational viewpoint. Second operational viewpoint is that we then see if the production typically would be collecting this data. Then you would also typically have a technical department or maintenance department who could use this data point to do the maintenance. Let's say we want an alarm when it's in this idle state because it's out of the tolerance, or we need to look at this. And then thirdly, we see it also from the technical department viewpoint, is that if they need to say, we want a new machine, it's both the production, for example, to say, we need to invest here, or the production engineering department to say, we need to invest here, we need new robots or automate things, we need to hire more people. Then they would often get asked, have you got a business case in turn? Have you, the CFO will ask them that. And there they often need data to say, we're spending this much energy. We can get some equipment that uses 20% less energy doing the same job. Then you can calculate the business case.
And is these calculations and these also collecting this data, is that something that most production companies, larger production companies do already? Or do you still see many companies out there not collecting this, I would say, fairly basic kind of data?
Yeah. And that actually leads me to the fourth group where we see it being used. And that is where it's being used mainly already. And that is if you have a CSR department or ESG department or sort of an regulatory department. They would often be the ones, if you already make an ESG report, typically we see that ESG report is made out of the energy data that you have from your main meters. And that is often 1 meter per one location often.
Okay.
Or one facility. That is really the level.
So that could be an entire factory.
An entire factory could have one energy meter. Mm-hmm. And that department will already use the data if you have such a department. But of course, the ESG reports, it's not so long ago that it started, so people are then wanted to have more fact-based, how much did you actually use in this department, or what is, you have one product that is accounting for 80% of your production. What is the energy consumption of that? So you can really, and that is where we see the drive, and we don't see that many companies have these sub-meters. Okay. So let's call it detailed energy data.
Okay, perfect. So I think moving on to the next data insight that you identified, we're talking about competitiveness and efficiency. Again, somewhere where collecting data seem very important. What kinds of data collection are we talking about here?
Yeah, it depends on what you're producing and what industry you're in and so on. So of course there's difference if you're a logistics facility to if you are a pharma company or a food company or work in the metal or wood industry. There are different KPIs and therefore also different data points. But some good ones to start with is to understand how efficient are you in your production process, whatever you're actually producing. And that could look at a data point to say, I have some physical assets. Could be machines, could be robots, could be lines, could be even manual workstations. I want to know how much of the time I have on my shift are my machines actually running. That's a very good data point. So simple up and down time. And after that data point, you could then dig a level deeper to say, if I have downtime, I now want to know the root cause of the downtime. That you can collect automatically as well, or manually. That's some data points. Other data points, if we're talking efficiency, could be to say, I have planned that I can produce 100 per hour, but I actually want to know how many out of the 100 am I actually producing. I'm producing 75, for example. Then you can calculate, okay, we still have 25% to optimize here. Should we, if we go faster, does it then affect the quality?
Moving on to the third bullet, one data point, and it has a different nature. We talk quality, so data-based insights on product quality, and that's both whether is it broken or is it not broken? Can we sell it? Can we not sell it? But also in the quality process. And of course, quality process is very important when you look at pharma and food, and then gradually less important depending on what you're selling. But can you talk into how are you collecting and what kinds of data are you collecting when we talk about quality?
Yeah.
Or the forerunners of operation management?
I think I want to divide quality into two buckets. Number one is what I would call sort of product quality in a way. And the second one I would call it would be sort of compliance quality in a way. If we start with the product quality, then it's quite easy to actually put some sensors up that can look at the actual physical quality of a product. Are the holes drilled in the right way? Has it got the right color? Is the lid properly on? Does the product look like we want it to look like? Is it within the standards, and is it within the tolerances that we allow the product to be? Because in all over the world, quality is really a parameter that you use in your sales product. On your sales process, you need to say, well, our quality is this. If you say deliver product, you have to make sure that the quality is there. So that is the number one thing where you can. And right now the technology has really evolved. Cameras, we're sitting here being taped by new cameras. We all know how that worked on the personal side, and the same has happened on the industrial side, where the quality of cameras and what we can do there, or the whole vision-based, or again, machine learning and AI, combine that with some pictures, you can really do a lot automatically these days on the product side. And that leads me into the second point, which I would call the more process or compliance quality side of things, where let's say in specific industries mainly, but we definitely see it trickling down to many industries, is as much that we all know the ISO certifications, or that you can, every product now have an environmental product declaration, so on. But you have to back these declarations up. So and you have different standards that you have to meet. And again, that's another way of quality where it's not so much on the actual product. It could be that we need to know that the temperature within our production environment, no matter what we're producing, is a certain temperature all the time. And right now, people, you can go around and collect that manually, or let's say read it manually. But technology has evolved, so you can now quite easily install temperature sensors, for example, or collect the data from whatever processed or quality data that is important.
Yeah, so this type of quality is more of a formalized quality measure. It's for reporting, a lot of it. Yeah.
It's for reporting and making sure that the data points that is within your quality process is there, but it's also making sure that your process of reporting it is important. So you do not need to have 5 people collecting data. They put it into an Excel, and then some people put it into another system, and then it's being stored in a file cabinet. It's more that you can now actually collect this once, and then you can actually do maybe the only management by exception. So like only check it if it's not within the tolerances. You can really change your quality process and your man hours by using data, really.
And Stefan, is this way of collecting data, is that something that is right now only for the front runners in production? So the large production companies, the big factories, global selling, is it only those guys using this kind of data collection and quality collection or quality data collection? Is it reserved for those guys, or is it already trickling down to middle-sized companies, even smaller production companies? What do you see? Is it only front runners, or
Yeah, you, like in every industry, I would say you have some front runners and some lighthouses out there who both have this, let's say, continuous improvement mindset, the belief that data is important to drive business and sustain to be in business, sort of a license to operate. But you also have large companies who is very, very manual. So they might live up to compliance or regulatory structures, but it's very, very manual, time-consuming to uphold this process of having to report all this data. It requires a lot of people, a lot of cumbersome processes. So I see both.
Okay.
And I also see smaller companies who have this mindset of data-drivenness and reporting, even though they actually don't have to, but they choose to have it as a competitive parameter, as a brand, or as a culture in a way as well.
But it really also seems like something that would be a competitive advantage, both in terms of if you automate this process, invest in automating it, you can save a lot of man hours. And having production in Europe or even in Denmark is going to be very expensive to use a lot of man hours. Well, even if you have the production in China, it can still be beneficial to not have people walking around. And then you also have a much smaller error margin. Yeah.
That is the point we see. It's the whole people. You're prone to errors. We all are, and that is the good side of the human race in a way. But you might have to change your mindset to use humans to instead of using humans to collect data, write down data. We might use the manpower to look at the data or analyze the data. And that is really the key.
Now you did already mention a little bit of it, but how are these companies collecting data on the quality process, both on the quality process, but also on the product quality? How are they using that in the navigation of the production?
They're using it in a way to again on the 3 levels really. So it could be that instead of an operator having to check something manually, could be measuring something simply. They don't have to measure it anymore. They only have to. They will have a notification if the camera or the vision solution has said it is not within the tolerances. Then they have to act. So instead of spending time on actually measuring, they can spend time on controlling or actually adding value to a process. That is one good example, I would say, that, and it's quite practical because there's a lot of manual measuring out there, really, manual registrations, and that is what practically you can do with a lot of equipment these days.
All right, moving on to something I think is quite exciting and a quite exciting use of data. We're talking about maintenance. So preventative maintenance, predictive maintenance, these kinds of things. Can you try and explain how you can use data insights, data-based insights in your maintenance?
Yeah. It's I touched upon it in the early beginnings, but we see a lot of maintenance technical departments, like in our personal calendars. You do your maintenance or your tasks based on a date, or a specific time.
Mm-hmm.
And it's also because machine manufacturers, they will often have, you have to do this after X amount of running hours.
Mm-hmm.
After X amount of years.
Yeah.
So that is what we see out there. But we definitely see a drive, and the front runners are starting to use data and data-driven maintenance. And that could be to say, well, we now want to do all our maintenance based on running hours, could be based on vibration.
So just to get it right, so instead of having a date-based or calendar-based, it's when this time has gone, we will need to do maintenance. Instead of having that, you will then look at the actual machine and I'm just saying, hear and feel how the machine is.
You will actually,
and then only take it to the doctor if it's actually broken or beginning to break.
Exactly that. You can still have your calendar-based maintenance in a way, and continue with that. But as an added value, you will also know, well, actually, this machine has only been running X amount of hours within this calendar period. And then you can really prioritize your maintenance tasks based on that. So it's, again, you have this data foundation to do your prioritizations from. So you can be very efficient with it. And especially if you're order producing, where you're not running full capacity or you're not running 100% of the time all the time, then it's quite useful to, for example, know the running hours. If you have a line that's just running 24/7, then it might be some process parameters. Vibration. Is there something that is vibrating? Are we using more power than we normally do? And then you will have your curve. And you can say, well, when it's when it's 20% over what it normally is, maybe we should prioritize looking in.
Mm-hmm. I know that this way of measuring the machine, so to say, I know that type of measurement, you say vibration, you say temperature, these kind of things, it's already been out there on the market on what you would say like hard to reach products. So that could be offshore wind farms, for instance. So you'll have a sensor measuring whether it starts vibrating in the gearbox, because that's quite important to fix it. But it costs a lot of money to go there and fix it. And it costs a lot of money to go there just to check, right? Are there any industries where this is more important? Obviously, these kinds of industries, but also in regular production, you have your factory out here in central Denmark, something like that. Are there any industries where it's more important, or any parts of a production line where it's more important than others? What do you find?
Yeah, we find that you can sort of divide it into two pockets again. where you have what we would call continuous production, sort of a line-based production, where you have a long line or with some process involved. That could typically be food, or it could typically be farm industry, where when you're running, it's a long process or long line that is just running. And so you might have some process doing something first, and then you have some packaging later, something like that. And then you have the other bucket, which is more, let's say, order-based, where it's more like you can run full capacity for this week, and next week you only run 50% of your capacity on this machine because you don't have any orders that fit that machine. That is the two ways of production that we see. And in terms of maintenance, I think you can. It depends on if you're the one or the other. For the continuous production or the line production, we find that process data is more and more important. Because if you're not within your process parameter, if you're not within the right temperature, if you're not within the right humidity, if you're using more power than normal, so you have a breakdown. If you have a breakdown there, then it's your whole process that is stopping. You cannot do anything. It's everything that is down. So that it's really critical also for the product.
It can cost a lot of money for every hour
a lot of
spent.
money, exactly.
Yeah.
Whereas we see it on the more, if you have a cell that is producing or a single machine that is producing, then you can use that data to actually more strategic in a way, to say plan your maintenance, because there's more not so simple in a way, because you have a lot of things, a lot of assets you have to maintain, and the data can really help you to give that overview of picture of, okay, where should I start? What should I prioritize?
That's brilliant. I think I want to move on to the last point that we have, cost. And collecting data on cost, it seems a little bit the wrong way around somehow. But can you explain what do we mean by collecting cost data?
Yeah. Typically, you would have, and that's a big driver that we see that that financial departments or planning departments or CFOs actually dive into really production data. And the reason for that is it's now available or accessible to actually give the actual production costs of a part or of a whole order, or per day or per month, because often it has been based on quite historical data or some planned data where you assume something. You have your goods, what your hard goods, then that has a certain cost, and from there you might have some man hours, and then you divide it out where you think, okay, it takes this amount of time. That is my cost, and if we're within that, then it's okay. But with data insight, you can now really, tell, is it 5 hours? Is it 5.5 hours? Or what is it? And each hour, each minute is important in the full picture. So that is where the cost, where data can give you the real cost picture, which you can then use to take strategic decisions to say, should we continue producing these products? We can see we're always, using more hours than we actually plan to do.
Yeah.
Do we need to invest in new equipment because we cannot produce it within the calculated cycle time? It could be that you have various products and you want to know which order should I produce my products in. What does make sense? All of this you can now.
And how would you collect this data?
That is by using all of these data points that we have talked about.
Yeah.
The most simple form is simply to measure how long does it take. So I have both my real start time and my real end time for an order.
Yeah.
Because a lot of places now you can maybe start some orders, and then they are all finished at the same time. But you actually don't know how long each order took.
Or each item. Yeah.
Or each order, yeah. So that is a good way to start there. Because what we see often when you have the actual time of an item or a production order, then you also want to know, why did it take this amount of time to produce it? How much time were we stopped? How much time was the labor time? And again, when you have that timing, you can then say, it was 4 hours. Within those 4 hours, we actually spent X amount of kilowatt hours in those 4 hours. And then you actually have your CO2 emission or your kilowatt hours per order.
Which is going to be more and more important in the future also.
Very much a competitive measure, yeah.
Yeah.
Or metric of sales, really.
Yeah. I think we've covered everything. I'm just looking down my questions, and I think we've covered a lot. So we've covered data points in energy, so collecting data in energy. We've covered efficiency measures, competitiveness also called. So how efficient is the production line itself, but also each machine down to the machine level. We've covered quality, the two different kinds of quality. So we've got the product quality and the process quality, the more formalized documentation kind of quality. And then this maintenance bit, the preventative maintenance and predictive maintenance, and moving away from calendar-based maintenance to, is it broken or will it soon break? That kind of thing. And then, of course, it all compiles into looking at the cost, having some sort of aggregated result based on all of these, and actually knowing how much does it cost to produce an order, not just what we think, but what it actually costs. How many companies, on the last bit here, how many companies are actually succeeding in this?
Oh, that's a good question. We haven't looked into the statistic. We haven't, to be honest, asked all our customers on this question. But I would say it's a question that they will talk to us about, because it's one of the most interesting things for all manufacturing companies or industrial companies.
It's what they live for.
Yeah,
right. It's their life.
It's the bottom line, really.
Yeah.
So it's what you use to make your bottom line. So.
Yeah.
So when you have some data to be able to actually tell that, then you can really drive your business from there.
And I know that the large manufacturing companies, the large production places, the large food manufacturing places, they have this in place. They have a pretty good sense of this already, because the throughput is just so high that if they didn't, it will just escalate. How long time do you think it will take for these kinds of measurements and this more precise decimal-based, data-based insight into your production? How long time will that take to trickle down into the medium-sized and smaller companies?
We see it already now. So I would say if you are a small or medium-sized company, now is the time to act, because the SMEs or the medium-sized companies that are doing this now, they will soon be in another league where you cannot. Of course, you can catch up, but then you're not. Someone else is supplying to the larger company.
You don't want to play catch up.
Yeah.
Right. Yeah.
So we definitely see that some companies are doing this now, and the systems, technologies, and the mindset, I think, in a way of the whole digitalization landscape. The foundation is there. All the tools are there. It's really just to now act on it.
It's going to be very exciting to look at and also to follow. Stefan Jensen, thank you so much for joining this interview and coming with your insights into what kinds of data insights and data points people are looking at out there. The front runners are looking at. It's always very exciting.
It is.
Yeah. So thank you so much for joining, and hope to see you again.
Yeah, thanks to you. Thanks for having me.